Welcome students and dear parents to our session for discussing the JEE Mains question paper. I am SRIKANTH SUNIL, senior most faculty at the VISHRA IIT JEE Academy located at BALAPUR Crossroads. Today I am going to discuss the 23rd of January phase 1 morning session chemistry paper. I am chemistry faculty. So we will discuss the chemistry paper now. So welcome students to our live sessions of discussion of these classes. Hope that these classes will be very informative and very important for you. Those who are about to write the examinations, my congratulations to you so that you can write the examination well by preparing to the NEET. Okay. First question in the chemistry paper morning session is, which of the following compound can react with Hinsberg reagent? This question is from organic chemistry, and in organic chemistry it is from amines. So generally we know that amines have nitrogen with a lone pair on that, and they will have two hydrogens. Here they can be an R group or they can be an aryl group also. R group or aryl group also. So whatever amines are there which are having hydrogen, at least one hydrogen or nitrogen, they will react with Hinsberg reagent. They will react with Hinsberg reagent. So let us see how the Hinsberg reagent, what are the options that are given. First option is aniline itself. Yes, aniline is a compound with two hydrogens on nitrogen. Second one, N-N dimethyl aniline. N-N dimethyl aniline is aniline with nitrogen and two methyl groups on that. Two methyl groups. And the third compound is methylamine. Third compound is methylamine. Methylamine is CH3, NH2. Yes, this is also having hydrogens on nitrogen. And the D option is N-phenyl-aniline. So this one is aniline with nitrogen, and there is one hydrogen here. Another hydrogen is replaced by another aniline. So you can easily guess that here nitrogen contains hydrogen. Here nitrogen is not having hydrogen. Here nitrogen is having hydrogens. Here nitrogen is having hydrogens. So A can react with Hinsberg's reagent. C can react. D can react. But this D cannot react because there is no hydrogen on nitrogen. So our option will be A, C, D is the option. Option is A, C, D. Like that we can explain this. This is from the amines, nitrogen containing compounds. So let's move to the second one. This is about the stability of the carbocation. Stability of a carbocation. So let us see the second one. Second question is stability of carbocation. So they have given first option. They have given this cation, which is having minus here. In fact, they are giving carbanions, not cations, carbanions. First one. Second one. This is this compound, which is having minus sign here, and this is having this. Third one. This is the structure. Third one is like this. There is a cyclohexane ring and there is a minus. So students, most important thing that we have to tell here is aromatic compound. If there is an aromatic compound, that aromatic compound will be very much stable. Among this one is most stable because it has aromatic nature. Aromatic nature. How the aromatic nature comes? Observe this structure, students. Observe this structure. Here we have two 5 electrons, here is 1 electron, here is another electron, here there are 2 electrons, and here minus charge also has 2 electrons. So we can say total 6 electrons are there. Total how many electrons are there? 6 electrons are there. This is following planarity as well as it is following the Huckel's rule. Huckel's rule means 4n plus 2 pi electrons are delocalized. So that's why this one is related to 6 electrons. So we can say the option is 2. So let's go to the third question. Here in third question they are asking about isomerism in complex compounds. Remember students, metal with A 3 ligands, B type of ligands 3. This type of metals, they show facial or meridian. Facial or meridian isomerism. Facial or meridian isomerism is shown by this type of compounds. So that's why in the options given, the best option is this one, CO, which is having NH3, 3 ligands, and of course with that chlorine also 3 ligands. So this compound matches with this. All the others are not matching, that's why they are not the answer. Because this is matching, you can say that this one is the answer. So let's go to the question number 4. Question number 4 asks about pair of ions which are having same color. So question number 4 I can write like this. This one is question number 3. Question number 4 I'll explain here. Question number 4 they gave sets of ions. Titanium 4 plus and vanadium 3 plus. This one is colorless. No color. This one is green in color. This is option number 1. Number 2 option, let us see, chromium 2 plus and there is a copper 2 plus. Both are blue in color. So we can say that option B is correct. So they have given a set of ions. They are asking us to identify which ions, pair of ions which are having same type of color. And in the same way other ions are also given in this chromium 3 plus ion and nickel 2 plus ion is given, and also they are given manganese 3 plus ion, and of course they have given iron 2 plus ion. All these are having different colors, but these 2 ions have the blue color, so this one is the option that we have to select. So next, 5th question. This one is also very easy question. All of you know that osmium, iridium, platinum. Osmium, iridium, platinum. They belong to 6th period. Of course, here gold, here palladium will come. When palladium is coming, above palladium, of course, nickel will be up. So palladium is in the 5th period. So what is this question? This question is very simple. They gave osmium, they gave iridium, they gave platinum, and they gave palladium. They are asking which element is not in the same period. So these 3 are in one period, this one is in the another period. So palladium will be our answer. So let's move to the 6th question. This is question number 5. Let us move. Remember students, this is just a memory based paper, so eventually this is written by our students. So we are doing this on the memory basis. So this paper may be correct up to 90%, and most of the other points also we have to collect. We'll see that afterwards. Up to 90% we can say that we can rely on this. So next, question number 6. Question number 6. This is about aldol condensation. Aldol condensation. In aldol condensation, they gave two compounds, CH3, CH2, CHO, and there is another compound which is HCHO. This is formaldehyde and this is normal aldehyde. Here there is no alpha hydrogen. Here there is alpha hydrogen. And remember that they have taken OH minus and they are refluxing. Refluxing means high temperature heating. High temperature heating. So how the reaction can be explained? Let us see. First of all, when these two are combined, we can get a compound like this. This one we can take excess. This one we can take excess. So let us see how the reaction takes place. So excess. This one is excess. So CH3, CH2, CHO plus 2HCHO. 2HCHO gives you this compound CH3, C with CH2OH, and here also CH2OH, and of course here CHO is there. First this type of compound will be formed, and after that another HCHO can be understood, reacted with this, and finally a Cannizzaro reaction. Cannizzaro reaction takes place. So final answer we can write like this. CH3, C, CH2, OH, and here also CH2OH, and here also CH2O will be oxidized to CH2, or in fact reduced to CH2OH. So this one is the answer. This one is question number 6. Very interesting, slightly important and difficult problem. So now let us see one more easy problem from inorganic chemistry. All of you know that sulfur dioxide is having oxidation state +4. Sulfur dioxide is having oxidation state +4. So it can increase its oxidation state to +6, and it can decrease its oxidations to +2 or 0 also. +2 or 0, anything less than this. So the one which decreases when it decreases the oxidation state, it can act as an oxidizing agent. When it increases the oxidation state, it can act as a reducing agent. So SO2 acts as both oxidizing agent as well as and reducing agent. Both natures are there. So here they have given 4 options. In this, why I am explaining about SO2 is because that option is actually correct. They are asking the incorrect statement among the following. First one is SO2 can act only as an oxidizing agent but not as a reducing agent. That of course, according to this explanation, you understood that SO2, this point is completely incorrect. Then NO2 exists as dimer, yes, and PF5 exists but NF5 does not exist, yes, and PH3 has lower proton affinity than NH3, that is also correct. So the incorrect statement will be the SO2 can act only as oxidizing agent but not as here, because it is acting as both. So that is an incorrect statement. So that will be the option for us. First option will be taken. So now let us go to the 8th question. Question number 8. So considering this very interesting question, here there is an aromatic compound. This aromatic compound is having CH3 and here NO2 is there. So first, bromine will be added in the presence of FeBr. Generally, bromine will be added to that in the ortho or para positions. So, in the ortho or para positions means we can expect the compound to be like this. Here Br is there, here CH3 is there, and here NO2 is there. Okay, now you are reducing that NO2. So for that, tin in the presence of HCl is added. Then this two oxygens will become two hydrogens, so it will reduce. So the compound is now becoming like this, converting like this. Very interesting. 2 or 3 concepts are involved in this. So students, please understand that. Practice in this way. This is how you can write this NH2. Then this reaction will start, will do the diazotization. Azotization. Diazotization means what you will do? NaNO2. NaNO2 at 0 degrees Celsius, we are going to add to that. Then this compound will become diazonium chloride. So here comes the diazonium chloride compound. Diazonium chloride N2 plus Cl minus. N2 plus Cl minus. Now you are using phosphonic acid. What is phosphonic? H3PO2. Hypophosphorus acid is H3PO2. Then this one will be converted into this compound. This one is orthobromotoluene. The molecular weight of this one is the final answer. Molecular weight you calculate, molecular weight is 171 grams per mole. So answer of the molecular. So first option is like this. This one will give this, this one will give this, this one will give this. They are asking the molecular weight of the final last left compound. This is the last compound, a major compound. Find out the oxidation molecular weight, that will be 171. Very simple. Okay, now let us go to the next question. In this next question, we will study about the shapes of the molecules are extended. So see here, there is a match the following. Match the following is there. In this match the following, BF3, boron trifluoric is there, CCl4 and CO2 is given, and here PCl5 and of course BrF5 is also given, and MO is given. Opposite to this, they have given some column number 2. So column number 2 is odd electron species. In this, which one is odd electron, you have to find out. Then this one is expanded octet. Expanded octet, then complete octet. Complete octet. Then after that, electron deficient. Electron deficient. So remember, third A group boron is electron deficient, so we can match this one. This one is an odd electron one, we can match this one. This one has a complete octet. This one is an expanded, more than 8 electrons will be there. So this one should be the matching. So different options are given, in that you have to select the proper matching option. That's the simple thing. So this is how you can understand this. BF3 is electron deficient, only 6 electrons are there. Here in this exactly 8 electrons are there. In this more than 8 electrons, here there is an odd electron. Remember that there is an odd electron. NO, not only NO, NO2 also has odd. The next time if they give NO2, you can write that this is having odd electron. So that is how you can understand this. Let's go to the one more question, that is also match the following. Match the following is very interesting, students, because they will be giving 4 or 5 options. In that, at least 2 or 3 if you can match, and the remaining you can analyze that. Even though you miss matching one, you can get the answer easily by seeing the option. So be careful and cautious when you are answering that. Carefully understand all the options, try the different types of options and see. So you will get 4 marks easily. So let's go to the 10th question of this. 10th question, it's also a simple one. There is a chlorobenzene. In this chlorobenzene, they are adding sodium with a dry ether. This is one. Then there is a diazonium chloride, benzene with N2Cl, and to this they are adding CuCl plus HCl. This one is a Fittig reaction, this one is a Sand-Mayer reaction. And they have taken one more chlorobenzene here. Once again chlorobenzene comes, but this time they are reacting with CH3Cl in the presence of same sodium and dry ether. Again. And you have the Schwarz reaction, CH3Cl, when AgF is controlling the reaction. What will have? So this one is a Schwarz reaction. Match the named reactions. You know all the names reactions. This one is Wurtz-Fittig reaction or Fittig-Wurtz reaction. This one is Sand-Mayer reaction. This one is simple Fittig reaction. So these are the 4 options that we can write. Actually, these options will be scrambled, and they will be giving A near B, B near D, like that. So actually, I wrote the correct answer. Actually, you have to match this. So these are from the named reactions. So students, there are nearly 40 to 45 named reactions in our NCERT book. Before going to the examination, all of you, I encourage all the students to just go through all the named reactions, and you can identify the named reactions by seeing what is there on the arrow. Simply by seeing what is there on the arrow, you can tell what type of named reaction it is. So you can compare the named reactions and you can do the matching easy. So now let us go to the 11th one. Here cobalt 2 plus is given, and it's a magnetic moment. Magnetic moment is 3.83 Bohr magnetons. What is Bm? Bohr magnetons. So they are asking what is the crystal field splitting electronic configuration. What is that? Crystal field splitting electronic configuration. So let us see how we can calculate the crystal field splitting cobalt electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. So cobalt 2 plus will be simply 3d7, 4s0, 4p0 or 4d0, like that you can write. This one is our main important point. So let us see the diagram. All the electrons are there like this. They are paired in the first 2, all the other 3 are unpaired. So if 3 unpaired electrons are there, then n into n plus 2 whole root is equal to 3.83. So n should be equal to 3, and this fits this diagram. So if n is equal to 3, it means that it's a weak ligand. Weak ligand is there in crystal field. What happens? Crystal field splits like this. Crystal field splits like this. So weak ligand means here there are 3, here there are 2. This one is Eg, this one is T2G. Here crystal field splitting means what you can write? 1, 2, 3. It pairing up is not taking place, so 5. Next here. So what will be the electronic configuration, dear students? T2G5 Eg is to, yeah. This is the crystal's field splitting energy. I think all of you understood. So carefully you have to see whether it is a weak ligand or strong ligand. So observe carefully how we have done that. This one is the answer. Right? So let's move to the next. So question number 12. Question number 12. See, Lesson's test. What is Lesson's test? First you have to prepare sodium fusion extract. Sodium fusion extract you prepare. Then this one is used, generally this one is an ionic substance. So covalent compounds, they are converting into ionic compounds. First point. Next point is, yes, Prussian blue color is the test for nitrogen. Prussian blue color. It is test for nitrogen. So, Lesson test will make ionic compounds. That statement is also correct. Prussian blue color, if it is observed, nitrogen is present. Our test for nitrogen is obtaining Prussian blue color. This statement is also correct. So, statement 1 as well as statement 2, both are correct. This is our option. Actually, this is like assertion or reasoning. Both are correct. Both are correct, dear students. So, like that, we can explain. Both points are correct. This is from practical organic chemistry, you can say, or qualitative analysis in the first year topic. So, let's move to the next question. Quickly, we can complete this particular paper because most of the questions are moderate. Now the tough questions are about to come, so carefully all of you concentrate here. These may appear in your examination also if you have not written the examination, so prepare well for this type of questions. So practice these questions. Let us see question number 13. Question number 13, A is a gas and this one converts into 2B, which is also a gas. So they have given that initial pressure initial is equal to 0.6 atmospheres, and they have also given the rate constant K is equal to 4.606 into 10 to the power of minus 2 second inverse. 4.606 into 10 to the power of minus 2 second inverse. Remember students, second inverse means this one is first order reaction. Right, so this is a first order reaction. Find the pressure at 100 seconds. Time given is 100 seconds. What is the pressure we have to do? What is the pressure we have to see? Yeah, students, we have come to the 13th question now. 13th question is, A is a gas, gives a 2B gas. Pressure initial is given. A rate constant also given. From the rate constant units, second inverse, first order reaction, we can identify. So after identifying the first order reaction, let's move on to the first order reaction. You have to do the problem like this. A, which is a gas, is giving you 2B, which is also a gas. So initially 0.6 atmosphere is there, but finally 0.6 minus P, and here 2P will be appearing. P is the pressure that got decreased and 2P will be appearing. So we can use the first order kinetics reaction. Kt is equal to 2.303 log of initial by final. 0.6 by 0.6 minus P. So we have to solve this for P. P, when you solve this, you are going to get 0.594 atmospheres. Going to get 0.594 atmospheres. Now total pressure. This one is the total pressure. So find out total pressure is equal to 0.6 minus P and add this to P. So minus P to P, it will become 0.6 plus P. Already you got the P value, add this 0.6 plus 0.594 atmospheres. So this one is going to give you 1.194 atmospheres. This is the answer. Once again, I'll explain. Students, here initial pressure is given. I have written initial pressure. Final pressure we don't know, but this one, if P is decreased here 2P pressure will be appeared. So total pressure will be like this. And P calculated. Calculation takes some time. Takes enough time. Calculate up to the second or third decimal. Then you will get the answer. Substitute this answer here, and easily you can get this. This type of options, this type of problems on initial and final pressure, that too on first order kinetics are given. So just practice this and go. Next one. All of you know that fructose. Fructose is having a keto group, but keto groups should not give tolerance reagent test. They should not give. But in fact, fructose is a reducing sugar and it is giving tolerance reagent test. Even though it's not having the aldehyde group, it's having a keto group. Now the question is based on that. Fructose does not contain aldehyde group, but it gives tolerance test. Statement number 2. In disaccharides, if the reducing group are bonded, these are non-reducing sugars. Example, sucrose. But first statement, second statement, both you can say are correct, because fructose does not contain aldehyde group, but it gives tolerance reagent test. So in this, fructose will convert into glucose or mannose. Glucose or mannose. To some extent, it will be in equilibrium actually. Fructose will be in equilibrium with mannose or glucose. So glucose can give the test, mannose can give the test. So because of its conversion from fructose to glucose, it can give the tolerance reagent test, positive test. So that is the only reason. Otherwise, sucrose, of course, is not giving. That statement is correct. So first statement as well as second statement, both are correct. We can say both are correct. Now let us go to the question number 15. We are already done with the question paper, students. Almost we are taking the memory based questions which are given by our students. So see here. There is a wavelength. Wavelength is given. This is from the atomic structure, the most easiest chapter, which most of the students feel very easy. So this question is also easy. They are given the wavelength. Okay. They are asking to which transition? 3 gives 2 Balmer series. Second one. 4 to 1. It is a Lyman series. Third one. 5 to 2. It is also Balmer series. And there is a 4 to 3 which is also Paschen series. So we have to calculate that E is equal to HC by lambda. Lambda you convert into meters and you do the problem, and you have to use the Rydberg-Ritz equation. I'll give you the Rydberg-Ritz equation. 1 by lambda is equal to Rydberg constant into Z square into 1 by n1 square minus 1 by n2 square. Z square is for, of course, they said this is hydrogen. So Z is equal to 1 here for hydrogen. So substitute Z is equal to 1. Rydberg constant also you substitute and you can do. What is Rydberg constant? 109677 centimeter inverse is the Rydberg constant. Substitute that, can get the option. The first option will be correct. And in other way also you can guess. See here, 656 nanometers, which is in visible region. Which is in which region? Visible region. Remember, Balmer series is in the visible region. Balmer series is in the visible region. But Lyman and Passion are not in the visible region. So, most probably you can make this question 50-50 and you can understand that 1 or 3 only can be the options. Then you can easily calculate that this option you can check in that 3 and 2 you can substitute. 2 you have to substitute here, 3 you have to substitute here. For this 2 you substitute here, 5 you substitute here, and you can check that. Checking will be more and more easy, time saving also for you. I think all of you understood. So let's go to the next one. Question number 16. Question number 16. So in this question number 16, they have given us a compound like CO, NH3. NH3 ligands, X ligands are there, but chlorine ligands are 3 ligands. So X we have to find out carefully. For that, they have given 100% dissociation. 100% dissociation means alpha is becoming 1. 100% dissociation means alpha is equal to 1. And they have given delta TF depression in freezing point, that is observed to be 0.558 Kelvin, or they have given this also, they have given Kf value, the constant molar depression constant, that is 1.86. This is for water. So like that they have given this. So what is the formula? Delta TF is equal to I into Kf into molarity. Using that I value, you have to find out the I value and you can solve the problem. So generally this compound is given like this. The answer you are getting here is CO NH3 taken 5 times, 1 Cl inside the square bracket, 2 Cls outside the square bracket. So X is equal to 5. You will get X is equal to 5. This is how we can answer that. Then let's go to the question number 17. Question number 17 is also organic chemistry based question number 17. So let's do the 17th question also. 4-nitrotoluene. What is 4-nitrotoluene? Toluene with CH3 here, and here you have NO2. This one is 4-nitrotoluene. 4-nitrotoluene is treated with Br2 to get compound P, which is reduced to SnCl2. It is reacted with Br2 to get the compound. If it is reacted with Br2, you are getting the compound like this. And then you are using tin plus HCl, almost similar type of questions we got in the same paper. So this type of equation came before also. CH3, Br, and here it becomes NH2. After that, they did diazotization. Diazotization, yes, they have done diazotization. CH3, here Br is there, and here N2Cl is there. Then after that, they used phosphonic acid. Of course, they used the phosphonic acid here. Phosphonic acid, yes, we are getting this compound. So after using this phosphonic acid, what they did is they converted that into, they used oxidized alkaline KMnO4. Alkaline KMnO4. Then these compounds are gone and we are getting the compound which is oxidized to benzoic acid. So you are getting benzoic acid. Like that, we can give the answer, that is benzoic acid. So next, let us see one more matching is there. From thermodynamics, very easy. Volume change is delta V means isochoric. Then when volume is constant, then volume is constant, delta U is, and you have when no heat is exchanged. Delta Q is equal to 0, change in the heat is equal to 0, work done by the gas is equal to the heat given to the gas. All these options are given. In this, P is given for the first one, work when volume change is equal to 0. So you can write like this also, volume is equal to constant and they have given W is equal to 0. So this one can be written to this one can be written to this, heat change, this one can be written to this. This type of matching will be done and work done by the gas is equal to heat given by the system, isothermal. So that is option number, we can say that is P. So this is the options that we have to give. Next one, 19th, what is the stability order? Let us see the stability order. Always remember, aromatic is more stable than non-aromatic, which is more stable than anti-aromatic. This one is the order that we have to maintain. So here they gave some compounds. You have to identify. This one is anti-aromatic compound. There is a compound which is aromatic in nature. Yeah, this one is an aromatic nature compound. Instead of plus, I'll make it minus, because plus will be aromatic in nature. So you can make it minus. So see this minus, and then ఇది non-aromatic. So if this is first compound, this is second compound, this is third compound, yeah, we can write second one is the more stable than third one, and then comes the first one because aromatic, non-aromatic, anti-aromatic. So that is the order that we can write. Now let's go to the numerical based questions. Numerical based questions are there. So I think all of you understood. Aromatic first, non-aromatic, then anti-aromatic. Convert this into that order. That's all. So let us see. There is a numerical problem given. This one is there is a 2 grams of phenol is allowed to react with, this one is reacting with Br2 in the presence of H2O. Yeah, very good. And how much Br2 will be required to produce 2 comma, it is producing 2 comma 4 comma T tribromo phenol. So let's see the reaction. This one is phenol. Phenol is having OH and you have Br2 in the presence of water. You are getting this compound. where OH is still here, but BRs are surrounding the OH lines. BR. So for this, we have to calculate that, and 2 grams means 2 by 94 weight by molecular weight into 160 into 3 we have to do, and in this calculation we will get 10.2 grams. So nearly equal to 10 integer question. So make it nearby to 10. So 10 will be the answer here. So let's see some more questions here. Okay, question number 24. Let us see the question number 24. Question number 24, delta H is given. Delta H is equal to 55 kilojoules per mole. And delta S is equal to 175 joules per mole. And temperature is equal to 25 degrees Celsius. Then calculate delta G. Delta G, you are supposed to calculate delta G is equal to delta H minus T delta S. This one is the relation between Gibbs free energy, and you can calculate. So delta G is giving you 2850 joules per mole inverse. This one is the answer. So your numerical answer, you have to write 2850. It's a very big numerical, it's in thousands. Even then you can answer that. So next one and the last one is 25th question from this morning session. Here we have to calculate the Carrier's method. See here, barium sulfate. So sulfur can be estimated by barium sulfate. Its molecular weight is 233. Its molecular weight is 233. So what is the formula of sulfur? See here, 233 grams of sulfur is having 32 grams of sulfur. Of BaSO4 is having 32 grams of sulfur. So if they give you 466, so it will be 64 grams. Simple, make it double. This one also will become double. So 64 divided by 160 into 100. So 16 goes 4 times here. This one is 40%. So our integer is 40. There are a couple of questions which we are not able to set them properly. So of course, nearly 23 to 24 questions we are able to explain this. This is morning session of 23rd of January. So bye students, will be again.